All right, good afternoon, everybody. Thanks for being here. Welcome to this English session on building secure Angular applications. So maybe to get a feeling for who is in here, because this is not an Angular conference, who here actually uses Angular? All right, that's a majority. The other people probably don't speak French and had nowhere else to go. Welcome. That's okay. So maybe a second question, who is still using Angular 1 and who's using Angular 1? Okay, that's quite a lot. And Angular 2? Okay, it's half-half. The code examples in the slides are actually Angular 2 or Angular whatever, just Angular for now. But I will refer back to Angular 1 when it's relevant. So it's very similar in both frameworks, what I'm going to talk about. So that should not be a problem for you. For the people who don't really use Angular, maybe not too familiar with Angular, I'll have a 10-second introduction to what Angular really does or what Angular means in a browser. Essentially, what it comes down to is with an Angular application, you no longer have a server-side web application. You have an API and you have static files, but you no longer render or generate HTML on the server, which is then rendered in the browser. So if I would visualize this, you have a browser on the left and a server on the right. Essentially, what happens is you have your server-side data, your API, you have some Angular code, which is JavaScript, or TypeScript, which eventually becomes JavaScript anyway, and you have some HTML code, which are templates, and that's essentially it. What happens is the browser will load this application first. You get that application in the browser, and the application is actually bootstrapped. So this is Angular running in the browser. On the server side, no Angular code runs, so essentially this is a client-side application. In the application, you have all of these placeholders where you can put data, which is called data binding, one of the core concepts of these JavaScript frameworks like Angular. And whenever you need data, you fetch it from the server with an API call, you get the raw data, and you put the data into your templates on the client side. And that's essentially what an Angular application does. Of course, this is a very high overview of Angular, so there's a lot more under the hood. But this is enough. You need to know about this kind of concept to be able to follow this talk. So if you have no previous Angular experience, you're going to learn some security stuff anyway, which you can then apply in other frameworks or in other applications as well. Before we dive into the details, a small word about me. My name is Philippe de Ryck. I have a name which is unpronounceable in French or English, so don't worry about that. My first name is pretty French, so that's good. You can call me Philippe, and you're good. I come from Belgium, and in Belgium I actually run a security program. I'm associated with the university because I did a PhD in web security, and I stayed there. But since then, I've been running a commercial program, security program within the university, targeted towards companies. And I do trainings, I do public talks at conferences like this, we do security assessments of applications, those kind of things. If you want to know more, there's a website with a lot more information. I'm essentially a security expert, and I specifically focus on web security. So, like I said, I did a PhD on client-side web security, but I have a broader overview of the web security landscape. So if you want to know a bit more than just about Angular, there's a book I wrote during my PhD, which you can check out, containing a lot of references towards other works as well. And finally, I'm part of the organizing committee of SecOpDev. SecOpDev is a one-week course in Belgium, where we essentially focus on developer-oriented security. So this is a very practical course where some academics teach and some people from industry. So it's a very good mix between both worlds, and we actually try to aim to teach you how to build secure applications and how to use the latest technologies in today's applications. That's enough about me. Let's talk about Angular. Let's talk about one of the most common vulnerabilities on the web, which is cross-site scripting, which is a very dangerous vulnerability. And let's see how Angular deals with that, or how you have to deal with this in Angular applications. A very quick recap about cross-site scripting. So in a cross-site scripting attack, malicious content is injected into an application. So what it really means is, this is a very simple example, if you have an input field like this to search something and you enter something that looks like JavaScript and actually is JavaScript, and that happens, you're in trouble. This means that somebody can give you input which results in the execution of script code. And that means that if an attacker stores a piece of malicious code in your application and the user executes this in his browser, the attacker now has code running in the user's browser. And that's definitely a problem. Again, this is in a very brief nutshell, because I don't have too much time to go into detail on that. Cross-site scripting used to be very simple, like you inject the script tag and that's it. Today, cross-site scripting is a bit more complicated. You have very advanced attacks, but you can also have attacks using CSS code, using HTML code, SVG code, all kinds of things. So cross-site scripting has definitely evolved a lot. When people talk about cross-site scripting, when people find a cross-site scripting vulnerability in an application, they typically show you a pop-up saying, giving you a little bit of information. And that might give the impression that cross-site scripting is about pop-ups and about annoying things, but it's not really that dangerous. Well, that's a misconception. So whenever you can show a pop-up, that's a proof of concept, there is a vulnerability, that means that you can essentially do whatever you want within that context. And one very good example is Beef. Beef is a browser exploitation framework, and this is a whole framework packed with all kinds of attacks you can launch from within the browser. And all you need to do to hook a browser is inject a very small piece of JavaScript code. The JavaScript code will call back to this framework that the attacker controls, and from there on he can launch all kinds of attacks just by clicking and doing whatever it wants. The example shown here is actually capturing images from the webcam, just like that, through a cross-site scripting vulnerability. So this is to show you that cross-site scripting is actually quite dangerous. Before we can talk about Angular, I'm sorry, I have to go back in time to these traditional web applications where we actually generate the HTML on the server, send it to the browser, and render it in the browser. Of course, the trivial example is PHP. This is a very simple code example where a username coming from somewhere from the client is echoed back into the HTML to the client. If you enter, well, let's say that the username comes from a URL parameter. If you have my name here, this is what will be generated on the server, and this is what the browser will do in return. If you insert some HTML instead of a username, like this, then the server will generate this, and the browser will execute something like that. And then if you inject a script tag there, this is the hook.js is from Beef, by the way, so if you inject this, the browser will get hooked by Beef and will be under control of the attacker. So the server generates this, and you see this in the browser, but in the background, this script is loaded, the script connects to the Beef framework, and you as a user are essentially, well, it's game over for you. This is cross-site scripting, this is how it used to be. How do you defend against this in a traditional application like this? Well, hopefully all of you know this, but in case you don't, let's go over it one more time. So essentially what you have is you have the output. What you should do is you should make sure that the output is safe to be put into an HTML page. So this function in PHP will take out the dangerous character. So if you take, well, if you had the blink tag from before, this is what will be generated on the server. So the open tag will be replaced, will be escaped for HTML, meaning that if the browser sees this, the browser will actually simply show you a blink tag instead of considering to be code and executing that. This doesn't seem too hard, right? So why is cross-site scripting such a problem? Well, because in reality you don't have this simple one line of code. You actually have a very big application with hundreds or even thousands of outputs. So you have the username here, you have some status, a color, and a username again. This is throughout the entire page, and you have plenty of pages. And the problem is this occurs in very different places. So you have a JavaScript context where you have some untrusted data. You have an HTML context like we had before, but you can also put untrusted data in attributes, which in this case is even CSS. You can put it in simple HTML attributes. And this makes it very confusing, because in an attribute, an open tag doesn't really mean anything. But if you have a quote here, then all of a sudden you break out of this attribute and you can start injecting additional stuff. And this is why cross-site scripting protection is so difficult. And essentially, the problem under the hood here is the failure to separate data in code. And this is something that we see in other places as well. This is throughout an entire web application. Once you generate a piece of code up front, which is then executed by a second service who loses all context information, like we have with SQL injection, then you are in trouble. And cross-site scripting is not different there. So now that we have this context, let's look at Angular. Like I said, one of the core concepts of Angular is this data binding. And data binding looks like this. So you can have the double curly bracket and then the name of a variable. And that tells Angular, I want to insert the actual value of username here in the page. So let's see what happens. Let's say we have the same example from before. We inject a piece of script saying no. What Angular will actually do here is Angular will see what you're doing, and it will generate this, and the browser will show you this. So essentially what's happening here is Angular sees that you're trying to put some data inside a page. It knows that it's data. It knows that it shouldn't be code, and it should never be code, what you're putting in there. So it automatically protects you against this kind of attack, simply because now it has the context information. It knows I'm putting this in there. It knows where it's going to put it, between HTML tags, so it knows this is safe to do if I escape the dangerous HTML characters, which is very good. Same if you do it for the blink tag, for example. This will be generated, and you don't see the thing blinking, but you actually see the HTML characters being rendered instead of interpreted as code. So that's already a good thing. But sometimes you actually want some HTML, and you don't want it to be escaped. For example, if you put a blink tag in there, you want the user to allow the use of the blink tag, which is probably a bad idea, but let's say you want to do it anyway. You can actually use the inner HTML attribute in Angular 2. And in Angular 2, this means that if you bind it to the inner HTML attribute, a piece of HTML, Angular will actually do this. So it will generate actual HTML code, and the browser will see this as HTML and execute this. This seems like a dangerous practice, but Angular 2 is smart enough to know when you put something dangerous in there, it will filter this out. So this is called sanitization. This is what you need to do if you want to allow certain pieces of HTML or certain elements in there, but not the dangerous ones. You need to sanitize the input, get something harmless in return, and insert that into the page. Like I said, I would refer back to Angular 1 where relevant. So in Angular 1, this slide, this practice already is already present, so it already escapes dangerous characters. And in this this part of the talk, so the sanitization, that's available as well, but you need to load the ng-sanitize module. So that's the main difference between both frameworks, but it's already available in Angular 1 as well. Angular 2 is just enabled by default, which is better. So one of the important lessons here is you need to respect the authority of the sanitizer. Essentially, the sanitizer knows what it's doing, so just accept when it sanitizes things, you're probably doing something insecure and it's protecting you out of the box. There are a few cases where you actually want to put some HTML in there without the sanitizer kicking in, and you can use bypass security trust HTML functions there. So essentially, Angular 1 had these functions as well, but they were just named trust as HTML, where you could mark a specific string as trusted, which means that Angular no longer considers it to be unsafe. In Angular 2, they renamed these to bypass security. I'm mentioning this because people often use these to bypass the protections and get something out there anyway, because it's very easy to get, to do, but you don't realize what you're actually doing. If you put untrusted data into this function, it will not sanitize it. It will simply mark this as safe, which is why it's called bypass security. Because if you do this with untrusted data, you will open up your application for cross-site scripting vulnerability. So you should be very careful when you use this. This is meant to be used for static snippets. So if you write something yourself, which is hard-coded, not dynamically generated from user input, then you can use this to output this into page. Just a fair warning here. So takeaway point number 1. Angular actually does a very good job in protecting you against cross-site scripting. So just let it do what it does best and get out of the way. That's the main lesson for cross-site scripting in Angular applications. I have recapped this on the slide, so you can refer to this or look at this later. The slides are online on my Twitter account and on my website, so you can find them easily. So if you want to recap this later, you can go ahead. That brings me to the second part of the talk. The first part was about cross-site scripting, but there's all kinds of untrusted code in a modern web application. If you think about what you're doing with an application, if you load an application, you first get your Angular library from somewhere. Then you bootstrap the application. Then you get some user data. User data is very dangerous if you simply trust it. We have cross-site scripting vulnerabilities there, so you need protection there. But applications also include components. You have advertisements. You have a Google Maps component. You have all kinds of different components that are embedded in an application. And essentially, all of this code is untrusted because the Angular library comes from some CDN. How do you know what you're getting? You're simply pulling in a file, and you have no idea what's really happening there. And the same for the user data, and the same for the advertisements. And that's why I want to I have 3 more topics to cover in this talk, so it's going to be fine. I have 30 minutes left, so that should work. But all of these things are untrusted, and there are actually security measures that you can deploy to either restrict the content that you're including or verify that what you're including is actually what you want. So let me go over each of these in the next part. The first topic I want to cover is SRI, or Subresource Integrity. So this is a mechanism that allows you to determine what code you're loading. So if you're loading the Angular library, like I said before, the only thing you have is the file name. So you tell the CDN, I want to load something that is called Angular / whatever version.js. And you get a file back, and this is an Angular file. But what happens if somebody replaces that file with a malicious file? Or what happens if somebody actually modifies the Angular library just a little bit to insert a backdoor, so you still get a working library, but you have a vulnerable library at that point? There's essentially, well, you tell them, I want this file, but you don't know what's in the file. You simply have to trust the CDN to give you the right file. And by the way, CDNs, they do a pretty good job security-wise, but there have been breaches in the past, and this thing actually happens in practice. So if this happens, you're compromised. Your application essentially is vulnerable because of the malicious file being included. The thing you can use there is Subresource Integrity. This is a browser security mechanism that has been available for about 2-3 years, something like that. And essentially what it does is it allows you to specify a checksum for a specific script. So it allows you to tell, you as a developer can tell the browser, I want to load the script from there, and the checksum should be this. And if it's not, I don't want you to load it because it's not what I wanted. So in our example here, you can specify the Angular library, specify the checksum, it's loaded, and the browser verifies this checksum. If it's correct, you get the Angular library, which is good. This is exactly what you wanted, and this is exactly what you're getting. And if you're getting something else, like a malicious file, the browser will say, whoa, this is not okay, this does not match the checksum you gave me, so I'm not going to load it. I'm going to give you an error, and I'm going to bail out because this file is modified without your consent or knowledge, and it should not be that way. So the good thing here is, when this happens, when the error happens, you're protected, that's a good thing. And you can, of course, you can load the Angular library from a second resource. So you can even host it yourself and load that in case of a failure, so you still get a working application without being compromised. This thing is actually very simple to enable. Many CDNs already support this out of the box, in the sense that if you want to include a library, you can easily go to the CDN, click the copy, and then you get copy script tag with SRI. The problem is, if you don't know what it is, it's very hard to choose that option because it's like, I have no idea what SRI is, so let's go with the default. But essentially what you get is this, you get the script tag with the checksum already embedded right in there. For CDNs that don't support it, or for your own resources or whatever, there's a website that easily generates these hashes for you if you want to. And they also include, a bit lower on that page, there's the commands you can run on the command line to generate your own hashes. Also very useful. Specifically for Angular, so if you include external resources, you can just use it like this. If you want to use it for your own resources, the stuff you build when you build your Angular application, the vendor.js files, you can enable this Webpack plugin. So there's a plugin for Webpack that automatically calculates the hashes when you build your application and already inserts them into your index.html files. So that's definitely something very useful. Browser support at the moment is a bit limited, so it's Chrome, Firefox, and Opera that support this sub-resource integrity mechanism. But other browsers will hopefully follow in the future. There's no indication on when this will happen, but since it's actually a very useful mechanism, it will happen in the coming months or years. The good thing is, it's an attribute. So a browser that doesn't know this attribute will simply ignore this. So even if you enable this already, people with a decent browser actually get protection, and the other people, well, they get what they pay for, right? So that's essentially the mechanism here. So again, takeaway points here. Sub-resource integrity gives you the assurance that you need about what you're loading. It's very simple to enable. It has limited to no impact on your application. So this is definitely something that you can start enabling on Monday, probably. All right. Next topic, content security policy. So CSP is a very complex topic. Let me introduce the main policy first, or what the goal of the policy, and then I'm going to talk about applying this in an Angular application. So CSP is, has been around for 4 to 5 years, quite some time already. And it was intended or designed as a second line of defense against cross-site scripting attacks. So CSP lives under the assumption that an application is going to be vulnerable to XSS at some point. Remind you, this was in the time of PHP applications with hundreds or thousands of outputs, and you need to cover each and every one of them. And essentially, history has learned or taught us that this is very hard and you will fail at some point. So with CSP, if you deploy a content security policy, you could actually apply a second line of defense. So in case an attacker is able to execute script, you can try to restrict him as much as possible in the hope that the attack is thwarted and essentially fails to compromise your application. And how you do it is you can set a security header, you can set a response header actually, content security policy, and you give it a policy. And the browser will receive that policy from the server and will enforce that policy on the specific web page. And what it does is, CSP applies 2 protections by default. First of all, it applies a whitelist. So if the script src says my script files can only come from my own website, not from somewhere else. So essentially when it encounters something injected like the attack from before, it will look at where is this coming from, evil.com, that does not match my own website, so I'm not going to load this. It will simply give you an error and say this is a remote script, it's not whitelisted. That's not what the policy says, so I'm going to ignore that and give you an error instead. The second thing is inline scripts are blocked as well. So this means that if somebody injects something like this, CSP will block this for you. Because inline scripts are, essentially it's a bad coding practice to have inline scripts. I know everybody does it, and that's unfortunately one of the evolutions of how we develop web applications. But CSP says that's a bad practice and I'm gonna block this by default because it's probably injected content anyway. Note that on-click handlers are also considered inline content. So at this point, you're probably thinking that CSP isn't very useful because if you have a traditional web application, it blocks all this kind of content and all your handlers, and that's something that costs a lot of time to fix. That's essentially one of the things that the people behind CSP discovered very early on when they released this, that it's very hard to do this in real applications. But what about Angular applications? Well, if you take a look at a very simple code example, what I have here is I bootstrap the Angular, I load some Angular libraries from the CDN. That's one thing, and there's an inline script block here. So what happens if you enable CSP on this application? We have the policy that we enabled here above, and essentially you get a huge list of errors. Well, at least some here. So at this point, a lot of people are like, whoa, too much errors, this thing is horrible, I'm gonna run away and just turn it off again, and I'm good, it's fine. I'm healthy and happy again, until, of course, an attack happens. But let me walk you through this. This is not as bad as it seems. So essentially, if you start looking at the errors, they actually make sense, because we have said scripts come from ourselves, and CSP says, yeah, but you're loading something from Cloudflare CDN, that's not your own website, so I'm not gonna do that. And here it says we have an inline script block, I'm not gonna load that either. So how can you solve this? Well, the obvious solution would be to simply whitelist the Cloudflare CDN. If you whitelist that, the errors here go away, these files can be loaded again, and again, everybody's happy. So we already fixed one of these problems. This is how people built CSP policies until last summer, essentially. So for a few years, people have been whitelisting hosts and adding them to the policy to ensure that the behavior is allowed in the application. Last summer, Google released some research and a tool to evaluate these policies, and it turns out that host-based whitelisting is a very bad idea, because a lot of CDNs host a lot of files, and essentially if you whitelist an entire CDN, people can include every file that's, or all of the files on that CDN. And some of these files have open JSONP callback endpoints. So you can provide them with a function, you get a script file in return, and that's executed, and you can bypass your CSP policy because you have whitelisted the entire host. A second bypass is related to Angular, but it pertains to applications that are not using Angular, and you can inject an Angular library and then do some fancy tricks there, but I'm not going to go into detail on that here today. So essentially, the main lesson that we learned last summer is that host-based whitelisting in CSP is a very bad idea. They analyzed a lot of CSP policies, and it turns out that 95% of them were bypassable. So that means that a lot of people put a lot of effort into building a CSP policy, to only have a bypassable CSP policy that doesn't do very much for you anyway, which is shocking, but it's good that we know that, so we can evolve towards better and more secure policies. So what should you do? Essentially what you want to do is you want to use nonces. Sorry. And a nonce is a random value you can add to your policy. So you say nonce dash and then random value, which is more random than the word super random, but it's to prove a point. And then you add the same nonce here in the script tags. So essentially what you do here is you tell the browser, here's my CSP policy. If you see a script block or script tag that contains this nonce, it has been put there by me. Because the attacker, if he injects something, he cannot guess what the nonce of the policy will be. So there's no way for the attacker to inject something like this with a valid nonce. Of course, nonces should be fresh and random on every page. So if I load the page one time, the nonce is going to be A7, B6, 12, whatever. And if I load it a second time, it's going to be something entirely different. So if an attacker wants to inject something that's actually loaded, he would be able to guess what a nonce would be, but that should be impossible if you have fresh and random nonces. So that's one way to avoid having to whitelist all of these hosts by simply adding a nonce here to the script tag. And the good thing is, nonces work for inline script blocks as well. So you can add a nonce here, and then this inline script block will be approved by the browser and it will be executed by the browser. That makes it already a bit more useful. So our application still works, but if you use something external, like a Twitter timeline or any other external code, essentially what happens is you can add a nonce to the first part of code. So for the Twitter timeline, I would add it here, the widget code that Twitter gives you if you want to embed this. Then you expect this, but actually you get some dirty HTML and you get a lot of errors because Twitter is trying to load resources from all of these different hosts. So this means that if you want to enable a Twitter timeline with CSP, you would first embed the initial Twitter code and then you get errors and you have to add platform.twitter.com and cdn.syndication.ymg.com and all of these hosts. And essentially, whenever the Twitter widget changes a bit, you may have to add additional hosts or modify this a bit, and that's kind of a nightmare to deal with. Believe me, I've tried. First of all, host-based whitelisting again. It turns out that Twitter has some JSONP endpoints, so just doing this already makes your policy bypassable. And if you want to use file-based whitelisting, so you can go further and whitelist a very specific file, but the Twitter files have dynamic file names and contain a lot of changing stuff, so that's also not very feasible. So that's one of the things that resulted in people actually going to host-based whitelisting. So what can you do there? Well, together with the discovery that most CSP policies use host-based whitelisting and weren't very good, Google came up with an alternative solution, which is called strict dynamic. And strict dynamic is a keyword you can add to your policy right here. And it essentially tells the browser that you want to enable trust propagation. And trust propagation means that if you have whitelisted the script with a nonce, so let's say that we added this block and we added a nonce here, this means that we already trust the code that's running in this block. So if the code came from Twitter, we copy-pasted this, we gave it permission to run on our website. So essentially Twitter, if it wants to do something malicious, it can do that already because it has code running on our website. And trust propagation says if the code that has been whitelisted is running and wants to load additional scripts, just let it. Otherwise, I would have to whitelist it anyway. We saw this before, I would have to whitelist all the Twitter hosts anyway. So with strict dynamic, the browser knows upfront if the Twitter code wants to load something extra, fine, let's just load it. And because we trust it implicitly using strict dynamic. So this is an improvement to make CSP a bit more usable, well, a lot more usable actually, because Google uses this internally as well. So they tried to deploy CSP with whitelisting and they decided that it's too much of a hassle and they resolved to this instead. So a way they propose to address this is you can build this CSP policy that achieves backwards compatibility and enables other scripts with nonces and strict dynamic. So what it comes down to is the policy shown above. And this is a policy that actually works in a lot of browsers, or in most browsers, but the level of security you get differs depending on the features that the browsers support. Let me walk you through it to see what this actually gives you. So if you have Chrome or Firefox, well, a recent version at least, this is actually the policy that you get. So instead of the full line here, you get the nonces, which we talked about. You get a strict dynamic, and yeah, let's ignore the unsafe eval for this talk. It's not too important here. So essentially, what is dropped is the unsafe inline, which would re-enable inline scripts, which is not a good way because it removes all protections. And we have a whitelist here that allows all HTTPS and all HTTP resources. So it's essentially a wide open whitelist. It doesn't do anything for you, but it's dropped again. Why? Nonces disable unsafe inline because they allow inline script blocks if you do it right, so you don't need this anymore. And strict dynamic disables the whitelist. So in that policy, you actually all your scripts that are marked with a nonce are allowed, and they are allowed to load additional resources. And that's enough to enable things like a Twitter timeline, a chat widget, or whatever things you can find online. If you have an older browser, this gives you all the protections that you want. If you have an older browser, they don't know the strict dynamic. This is something very new. So they would use the nonces, and they would use the wide open whitelist. So essentially what you get here is you get protection against inline script blocks because of the nonces, but not against remote scripts. So essentially, if you have a vulnerability, the attacker will be able to find a way to load malicious code anyway. Note that the application still works in these browsers. So that's the main thing about this policy. It's backwards compatible. Then if you have an older browser, like IE or Edge, you actually get unsafe inline and the wide open whitelist. So you get nothing, but the application still works. In all fairness, Edge is like in the middle here because the next version will be at this level. So they are working on CSP support. This is CSP level 1, the old one, CSP level 2, and this is level 3, which is under active development. So to be fair, Edge will be here in the coming months or so. Brings me to the takeaway number 3. CSP is actually, I admit it's a very complex policy, but if you investigate this a bit and play around with this, it actually allows you to lock your application down in case something goes wrong. For example, if there's a bug in the Angular sanitizer and there is some kind of a bypass, CSP would be able to lock down the power of the attacker and would be able to restrict what the attacker could do exploiting that vulnerability. Again, I've listed what we talked about. One thing I haven't talked about, in the last policy there was a report URI directive, and this enables CSP reporting mode. So essentially what this means is whenever a violation occurs, CSP, the browser, will send a report to this reporting endpoint saying that I found this violation there in the page, and it violated this policy directive for that reason. And this is very useful, first of all, to catch errors in your policy, but also very useful to find potential attacks when they're happening in the wild, of course. One final word about this. CSP can also be enabled in a report-only mode, which means that it doesn't enforce anything, it doesn't break anything if something goes wrong, but it will still send reports about violations. So you can try out a policy, dry run it before you actually deploy this in production mode, which is very useful again. All right, I had 4, so we're already at 3. Let's dive into the 4th one, sandboxing. Like I said, I'm talking about all of these kinds of untrusted code. This is the one that pertains to components, to blocks you want to put in your page, external components that you might that are untrusted and you might want to isolate them some way. One example, this is a screenshot from Steam. They had a security problem a couple of weeks ago, I think. Essentially what happened is they had user profile pages, and user profile pages allowed some kind of HTML in there, but of course not all HTML, but they forgot to filter out script tags. So this was a mistake, allowing anybody to put script code in their profile, and anybody watching or viewing that user's profile would get the attacker's script code and would execute this in his browser. Very big security problem. Why is this? How can you solve this, or how can you address this? Well, you can use a sandbox for that. And a sandbox is a feature from HTML5, so it has been around for quite a while. And essentially what it allows you to do is it allows you to restrict an iframe context in various ways. So if you simply add this one keyword, sandbox, you get an iframe context with the following restrictions. It runs in a separate unique origin. Even if the page comes from your own website, the origin will be something unique that never matches any origin nowhere in the browser. Scripts are not executed. Forms are not submitted. You cannot navigate external context. You cannot run Java or Flash plugins. you cannot go full screen, and you cannot use autoplay, and a few other smaller restrictions. So essentially, if you put untrusted code in this iframe, essentially it can't do anything. It can show you some very simple HTML, like the one on the profile page, the stuff you want to allow, but it will not be able to do anything harmful within the browser, which is actually a very powerful restriction that not a lot of people know about. Of course, it's very restrictive, so there are keywords to make it less restrictive. So you can specify attributes to, values to the attribute, saying that, okay, I want a sandbox, but I also want to re-enable scripts, so I still get everything else except for the not running scripts protection. And there are a few things that you can do. The only thing that you cannot re-enable is plugin content, so no Flash, no Java. So essentially, this is like a very happy place, the sandbox. And you have navigation restrictions that cannot not be re-enabled as well. So this is actually very useful. One fair warning, don't enable allow scripts together with allow same origin, because if you do that, the code in the sandbox can actually break out and modify the parent page and essentially render the sandbox useless. So either allow scripts or allow same origin, but not both together. So very practical in an Angular application. How do you use this to load a component? So essentially what you want to do is you want to put an entire block of the application into a sandbox. This works well if you have a Twitter timeline. That's something you want to put in a sandbox. That is something that you are allowed to do. So you can do it by simply adding a route in there. So if you do that, this will load another, this will actually trigger navigation. The navigation will be handled by Angular, and it will actually load a separate Angular context, because this is isolated from the outer page. So you will bootstrap a new version of the application here. That's why you need the allow scripts. There are ways to communicate with the sandbox. I will cover that in the next slide. If you want to share data between both, that is possible. But this is important to know that this is isolated from the rest, so it's not the same application instance running here. A few more lightweight options. First of all, you can simply load an HTML file in here. So if you have a modifiable profile that doesn't need Angular running, doesn't need data binding, you can simply load it in the iframe and be done with it. You don't need scripts for that. And even more lightweight, you can use srcdoc, which is also a new attribute in HTML5, to give a snippet of HTML right there without having to load an entire page. So this is different from here. Here you load a URL, you have a fetched page loaded. Here you actually give the HTML here, and you put it in the iframe. The browser will put it in the iframe for you. And those are 3 different ways to approach this, each with different levels of impact on your application. So how do you communicate with this? What if you want to exchange some information, exchange messages? Well, if it's same origin, you would be able to reach directly into the frame, but of course it's sandbox, so you cannot do that anymore. But there is an API to communicate with other browsing contexts, and that's called the web messaging API. And it comes down to using the post message function. So what you can do is you can simply get a frame and call post message and give it a message, and that will be sent to the context living in the frame. And the context can receive messages by opting into the message event handler. So you have an event listener, which is called message. You get an event, and you get the data from the event here. So this would be the message being sent here. You can exchange objects. The browser will copy them and send them through the API. So it's a bit more flexible than simply exchanging text messages. The reason I want to mention this is, again, security. If you receive a message, you need to be careful where it's coming from. So that's why this check is here. You need to make sure that if you receive a message, that it's coming from the context where you expect the message from. Because anybody can send you a message. Browser extensions also use post messaging, so you can intercept these messages as well. So you need to make sure, is this coming from my parent page, from the origin I expect it from? If not, I want to discard it anyway. If you want to send something, you need to specify the destination. But because a frame is running in a unique origin, there's no way to address that up front, so you need to use a wildcard there, which is an important detail that you might want to know about when you try to implement this. Sandbox is quite well supported, actually. So all browsers today support the sandbox. It took them a while since HTML5 was released. I'm not going to say which one was the latest, but let's leave that as a guessing exercise for you. But essentially today, every browser supports this, and you can actually benefit a lot from these kinds of protections. Brings me to takeaway number 4. Sandboxing is really powerful, especially if you have some untrusted code, which you're not even sure that you can sanitize. Maybe it comes from somewhere else. You can easily put it in a sandbox, and you can restrict it from doing certain dangerous operations. And again, I have listed this for you to refer to later. Brings me to the conclusion. First of all, we talked about sandboxing. So again, this allows you to put components in their own separate environment and isolate them from the rest of your application. We have CSP, which you can use to make sure that content running in your own context is restricted as well. So in case somebody injects code in your application, they will not be able to do as much as they would without the presence of a CSP policy. We had Subresource Integrity, very important to know that what you're loading is actually what you expect it to be loaded. Very easy to implement, so that's definitely something that you should enable by default in all your applications starting Monday, essentially. And then finally, we had Angular. Angular does a very good job in protecting you against cross-site scripting, so this is definitely something that you want to know about, and you want to make sure that if you encounter something in the console where Angular says, bad developer, go read the documentation on cross-site scripting, that's what I talked about here. So that's the moment that a bell rings and you go there and you actually read what they have to say, and you make sure that you don't bypass the security that they're offering. That brings me to the last slide. I essentially talked about security, but since I give trainings and do talks, that's essentially where it stops for me. You're the guys building applications. So you're the guys who have to actually apply these security principles and actually make your applications more secure. So that's step 1, and that's something that I can explain you how to do it, but that's something you need to take up yourself. Follow people in the security community. There's a lot of these technologies being added to the browser. A modern browser has over 10 of these security policies, like content security policy. It's really important to know about, at least to know about that they are out there, and to know at least what they do on a very high level, so you know when they might be applicable for your application. There are plenty of people talking about this. I talk about this on Twitter and in my mailing list as well. So that's one good reference, but there are plenty of others that are worth following to keep up to date with these technologies. And then finally, share. This is something I always tell people. If you implement one of these features in your application, if you do it right, share the message. Come back here next year and do a quick talk, like a quickie about this is how we implemented CSP for our Angular application, and it's really awesome. And that will inspire other people to take a look at it as well. There are blog posts from Dropbox and GitHub how they implemented CSP, and they're full of information about this is issues that we encountered and we solved it like this and this. And that's essentially what people need to get started with this and to build more secure applications. And then finally, if you want to know more, there's a security course. I'm hosting one in Belgium. So if you want to go to the country of good beers, which you also have here, but they're cheaper in Belgium, so that's always a good excuse. This is how you convince your boss that you need to go there. And also the course is quite interesting as well. So that's all I had for here. Thanks for listening. If you have questions, I think we have a few more minutes in the room, so I can answer them here, or I'll be outside if you want to ask me some questions there. Thanks for listening.